Previously, we learned the equation of an ellipse whose center is the origin. Now we are going to study the equation of an ellipse at any point. What do you think the equation of an ellipse would be when translating it h units horizontally? We would replace each x with x minus h. What do you think the equation of ellipse would be when translating it again k units vertically? We would replace every y with y minus k, so this is the equation of the hyperbola at the point h and k. What would be the vertices of the ellipse before translating it to the vertex h and k? The vertices of the ellipse would be positive and negative the square root of the greater denominator and 0. What do you think the coordinates of the vertices would be after translating the ellipse to the vertex h and k? The x-coordinates of the vertices would increase by h units and the y-coordinates would increase by k units like this. What would be the co-vertices of the ellipse before translating it to the vertex h and k? The co-vertices of the ellipse would be 0 and positive and negative the square root of the smaller denominator. What do you think the coordinates of the co-vertices would be after translating the ellipse to the vertex h and k? Similarly, the x-coordinates of the co-vertices would increase by h units and the y-coordinates would increase by k units like this. The same thing happens to the foci. To avoid memorizing too many rules, it is better to find them as if the center of ellipse were at the origin and then translate them to the new location. Let's have a look at this example. Find the vertices and the co-vertices of this ellipse. First, what type of ellipse is this? Since the greater denominator is in the y term, this is a vertical ellipse whose center is at the point 2, 3. So, the vertices exist on the y-axis and the co-vertices exist on the x-axis. What are the coordinates of the vertices of the ellipse? The square root of the greater denominator gives us the y-coordinates of the vertices of the same ellipse, but at the origin. Adding 2 to each x-coordinate and 3 to every y-coordinate gives us the coordinates of the vertices of the given ellipse, which are 2, 5 and 2, 1. What are the coordinates of the co-vertices of the ellipse? The square root of the smaller denominator gives us the x-coordinates of the vertices of the same ellipse at the origin. Adding 2 to each x-coordinate and 3 to every y-coordinate gives us the coordinates of the co-vertices of the given ellipse, which are 3, 3 and 1, 3. To sum up, the x-term of a horizontal ellipse at any point has the greater denominator and the y-term of a vertical ellipse has a greater denominator. The coordinates of the vertices are found from the greater denominator but translated h units horizontally and k units vertically. The coordinates of the co-vertices are found from the smaller denominator but translated h steps horizontally and k steps vertically.